So what we're going to do in this video is we're actually going to take our knowledge of the parent graph, and what we're going to do is we're going to transform it by using those values of A, H, and K. So we're going to tie it all together. How can we use the parent graph and transformations to create an actual accurate graph of any absolute value function? To start, we need to recap what we learned about A, H, and K. So what we're going to do is we're going to look at each equation below, decide what the A value is. Remember, A is multiplied out in front. Decide what the H value is, which is the number added to the inside of the absolute value. And then decide what the K value is, which is the number added to the outside of the absolute value. And then from there, we're going to determine how those transformations alter the parent graph. So that is where we are headed. Now, if we look at this first graph here, what I notice right here is this value multiplied out in front. That corresponds with A. So here I can see that I have an A value that is equal to 2. And what that A value equal to 2 tells me is that I have a vertical stretch by a factor of 2, which means it's going to get a little bit skinnier, a little bit taller. I'm going to stretch its height up and multiply it by 2. So that's what that A value of 2 out in front means. Then here I notice I have a value being added to the inside of the absolute value, and that corresponds with H. So what I'm noticing here is that H is equal to a positive 5. And remember, this is a horizontal change. H stands for horizontal. And then remember with H that these move the opposite of what we expect. So it's a positive 5, so it's going to move in the negative horizontal direction, which is left. So this graph is going to take the parent graph and move it to the left 5 units. So there's our first one. We can see we had an A and an H value, and we can summarize how those values are going to alter the parent graph. Now if we move on to the second example, what I notice here is I have an A value out in front of negative 3/4. So I have A is equal to negative 3/4, which the negative piece tells me that this is going to flip over the x-axis, or it's a vertical flip. It's going to flip the whole absolute value graph over, and then 3/4 is trapped between 0 and 1. So that means we're going to shrink it down, so we have a vertical shrink because we're shrinking down to 3/4 of its size. So it's a vertical shrink by a factor of 3/4. So we're going to shrink down to 3/4 of its size, which makes it wider. Then out here, I notice that I'm adding a value outside of the absolute value, which corresponds with our K value. And so K is equal to negative 5. Then remember, K is my vertical up and down movement. So it's my vertical shift, and it corresponds just as we would expect. So this is going to move that parent graph in the vertical direction, which is negative. So we want it to be down 5 units. So there's the first two. Then from here, if we look at that third example, I see a couple of different things going on. First, I notice that this value out in front is my A value. So I have A is equal to negative 3, which tells me that we're going to have a vertical flip because it's negative, or it's going to flip over the x-axis, and then it's going to vertically stretch by a factor of 3. So it's going to get 3 times taller than the parent graph. Then from here, I notice that this value inside of the absolute value is my H value, and my H value here is negative 2. And remember, it's going to move the opposite with the H value than I expect. Since it's a negative number, it's going to move in the positive direction, which is right 2 units. And then finally here, my K value being added on the outside. So K is my vertical movement, and it's a -5. So the graph is going to move vertically negative, which is move down 5 units. And then finally, we're looking at this last one here. So here what I notice is that I don't have an A value out in front. There's no value out there. So really we can assume that that's just 1 and staying normal. Then inside of the absolute value, what I see is that H is equal to 6. And remember that H moves the opposite horizontally of what we expect. So this is going to move, since it's a +6, in the negative direction, which is to the left, 6 units. And then here, this is our K value, because it's outside of the absolute value. And so K is equal to 8. That one moves vertically as we expect. So it's going to move up 8 units. So now that we know how to make predictions about how that child graph is going to change when compared to the parent graph, now we're going to jump in and we're actually going to start graphing these. And these are the 4 steps we're going to go through. What we're going to do each time is we're going to start with the parent graph table of values. So we've graphed the parent graph before. We're going to start with that parent graph table of values. And then we're going to start thinking through, okay, what changes do we expect? Based on the equation, what changes do we expect to see? Start thinking that through. Once we're done, we're going to apply the A value. So we're going to multiply all of the y coordinates of the parent graph. So essentially what this does is this step applies the flip, the stretch, or the shrink, depending on what combination of those you have. So we're going to take all of those y coordinates and we're going to multiply them from the parent graph by the A value to flip, stretch, and or shrink. Then finally, as we move to the graph to plot, we're going to move according to the H and K values. We're going to move that graph horizontally and vertically around the coordinate plane. So here to start off, I see I have y equals 3 times the absolute value of x minus 2, all plus 3. So some predictions, some things I expect to see on my graph. First, I see that A is equal to 3, so I expect to see some sort of vertical stretch up. I see that H is equal to -2, so what I know that means is that my graph is going to move in the positive direction, so it's going to move right 2 units when compared to the parent graph. And then I can see that K is equal to a +3, so the graph is going to move up 3 units. That's what I expect to see. So now what I'm going to do is I'm going to take my parent graph. So remember my parent graph, the x values were -2, -1, 0, 1, and 2. And then my y values were 2, 1, 0, 1, 2. And what I'm going to do here is I'm going to apply my A value to all of these y values here and rewrite them in a new graph. So my x values are going to stay the same. And I'm going to take each one of these y values. So for example, this 2. 2 times my A value of 3 is 6. 1 times my A value of 3 is 3. 0 times my A value of 3 is 0. 1 times my A value of 3 is 3. 2 times my A value of 3 is 6. So notice how I took all of these values in this red box and essentially stretched them to 3 times their size. So what I've done here is I've taken care of this piece. I've stretched those to be 3 times their size. So now our graph will be taller. Now, as we go to plot these points, that's when we're going to apply H and K. So as we plot each of these points here, what we're going to do is we're going to apply the horizontal and the vertical movements. So my horizontal movement is I'm going to move to the right 2, and then my vertical movement is I'm going to move up 3. So what I mean by this is I'm going to go to my graph, and I'm going to go to x is -2, y is 6. So that's about right there. And before I make a committed plotted point, I'm going to apply these two movements. I'm going to move to the right, 1, 2, and then move up, 1, 2, 3, and plot that point. So that is the point x is 0, y is 9. And then I go to my next point, and I say, okay, my next point is x is -1, y is 3. And I'm going to move to the right 2 and up 1, 2, 3. So here I am plotted at x is 1, y is 6. And then I go to my next point, and I say, okay, I'm at 0, 0. Right 2, up 1, 2, 3. So here I have x is 2, y is 3. Move to the next point. Then I see x is 1, y is 3. Move to the right 2, up 1, 2, 3. So that's the point x is 3, y is 4. And then I go to my next point, so x is 2, y is 6. So I move right 1, 2, 1, 2, sorry, up 1, 2, 3. So here I can see I have x is 4, y is 9. So you can start to see those all going into action. So now what I can do is I can take these and I can create my graph. And what I notice here is I have a graph stretched to 3 times the original parent graph's size. And instead of having its vertex down here at 0, 0, it's moved right 2, up 1, 2, 3. So I can see I've applied all of the changes I expected to see under my prediction category. Now the last thing I need to do is I need to determine my domain and my range of this graph. What I notice for domain is I'm going forever to the left and forever to the right. So my domain is all real numbers. And my range, I notice that the lowest y value I need is 3. And then I need all of the y values that are going up. So my range is y is greater than or equal to 3. So example 2 here, couple of predictions I noticed right off the bat from the equation. First, I noticed that a is a -1/2. So what this tells me is I'm first going to have a vertical flip because it's negative. And then because I have the 1/2 in there, and I'm going to shrink it to 1/2 its size, I expect to see a vertical shrink by that factor of 1/2. Then the next thing I see is that h is equal to 4. That's the number that's inside the absolute value. So h is my horizontal movement, and it's the opposite of what I expect. So this is going to go in the negative horizontal direction, which is left 4 units. And then I also notice that k is equal to -5. That's my vertical movement, so it's going to move down 5 units. So those are all of the changes that I expect to see. Now, just like last time, I'm going to start with my parent graph. So I have -2, -1, 0, 1, and 2. And then I have 2, 1, 0, 1, 2. So that's my original parent graph. And I'm going to apply the a value to get my vertical flip and my vertical shrink. So notice that my x values stay the exact same. And then I'm going to take all of these values here and multiply them by a -1/2 so that I can then get the shrink and the flip all applied in there. So 2 times a -1/2 is a -1. 1 times a -1/2 is a -1/2. 0 times a -1/2 is 0. 1 times a -1/2 is a -1/2. And 2 times a -1/2 is a -1. So I can take all of those points and I can plot them. But before I do that, before I plot these points, I'm going to think through, okay, I need to apply h and k as I plot them. So remember, we're going to move in the h direction, so horizontal. We're going to move left 4, and then for our vertical movement, we're moving down 5. So I'm first going to go to x is -2, y is -1. and I'm going to move to the left 1, 2, 3, 4, and down 1, 2, 3, 4, 5. So I can see that that first point is occurring at x equals -6, y equals -6. Then I go to this next point here, which is -1, -1/2, and I go to the left 1, 2, 3, 4, down 1, 2, 3, 4, 5. So that one's right snuck in there. And that's the point x is -5, y is -5.5. So just kind of pretend you can sneak that in there. Then from here we're going to 0, 0. Then we go left 1, 2, 3, 4, down 1, 2, 3, 4, 5. So here we're at the point x is -4, x is -4, comma, y is -5. Then we go to our next point of 1, comma, -1/2. When we go 1, 2, 3, 4 to the left, 1, 2, 3, 4, 5 down. So here I'm at the point x is -3, y is -5.5. And then finally we go to 2, -1. So we're then going to move that to the left, 1, 2, 3, 4, down 1, 2, 3, 4, 5. So here we're at x is -2, y is -6. And then I can take my straight edge and graph that. So we can see that this is flipped down, shrunk to half its size, and it was moved to the left 1, 2, 3, 4, down 1, 2, 3, 4, 5. Now my last piece here is to find my domain and range. I notice my graph is going forever to the right and forever to the left. So my domain is all real numbers. And my range are all of the y values that start at -5 and go down. So I have y is less than or equal to -5. All right, final example here. So I look at my equation and I study a, h, and k. My a value I notice is -2. So because a is -2, I expect to see a flip because of the negative number, and I expect to see a stretch to be twice as tall because of the 2. Then I also notice that h is equal to -1. That's our horizontal movement, and it's going to move the opposite of what I expect. So the positive h direction, or the positive horizontal direction, would be to the right, and it's going to move to the right 1 unit. Then because k is equal to 3, k is a positive 3, and that one moves as expected, so it's going to move up 3 units. So from here, now that I have an idea of what's going to happen, I'm going to start with my parent graph. So that goes -2, -1, 0, 1, 2, and then the y values are 2, 1, 0, 1, 2. And what I'm going to do here is I'm going to apply my a value to the y values. So I'm going to leave the x values alone. Those stay the same. My y values are all going to be multiplied by a -2. And what that's going to do is it's going to take care of the flip and take care of the stretch all in one fell swoop. So from here, as I multiply all of those y values by a -2, 2 times -2 is -4. 1 times -2 is -2. 0 times -2 is 0. 1 times -2 is -2. 2 times -2 is -4. So here I now have my new table where the a value is applied. And as I go to plot these, I'm going to apply my h and k values. So remember, in order to apply h and k, we're going to move right 1 unit, and we're going to move up 3. So I go to my first point of -2, -4. And I'm going to move right 1 and up 1, 2, 3. So we're plotted right there at x is -1, y is -2. Then my next point, we go to x is -1, y is -2, and we go right 1, up 1, 2, 3. So we're at x is 0, y is 1. We then go to the point 0, 0, and we go right 1, up 1, 2, 3. So we're at the point x is 1, y is 3. We then go to the point 1, -2, and we go right 1, up 1, 2, 3. So we're at the point x is 2, y is 1, and then we go to the point 2, -4, and we go right 1, up 1, 2, 3. So we're at the point x is 3, y is -1. So here we have a nice representation of our graph. So we're going to extend it. And then from here, we need to determine our domain and our range. I first noticed that it goes forever to the left and to the right, so our domain is all real numbers. And then from here, I noticed for my y values, they start at 3 and then they go down. We need all of those to make points on our graph, so we have y is less than or equal to 3.